Hello, my name is Russ Kennedy, and I'm going to give you a quick overview of the Nasuni architecture so you can understand how we deliver file data services to our customers. So there are a number of capabilities that we offer to our customers. We are a primary file storage platform. So customers can store their primary file data in Nasuni and deliver the level of performance that their users and their applications are expecting, just like they do today or would do today with traditional NAS storage systems, Windows file server systems, etc. We deliver primary file storage for our customers. We also leverage a continuous versioning file system, which allows our customers to eliminate the need to back up their data, their file data, because they can recover to any specific point in time for recovering of file data, an individual file, an entire file directory, an entire volume if they need to. I will talk about that in a little bit more detail, but one of the most important things that our customers say, the benefit that we bring to them, is that they no longer have to back up their file data. They get data protection across all of the different versions that we keep for them in the cloud. We also offer built-in disaster recovery. So that if a customer loses an individual location where they're serving file services, it's very easy to route to another location to get access to those file services, route to the cloud where they can get access to file services as well, or recover that location very, very quickly because all of the data associated with our file system lives in the cloud. It lives in either AWS or Azure or Google. And so they're very easily able to recover from an individual location loss, and therefore disaster recovery is built in. And then one of the key benefits that we offer to our customers is the ability to synchronize data across a number of locations and share that data actively, no matter where those locations exist. Many of our customers today are serving file services from hundreds of different locations, sharing data across those locations just like it's a single monolithic file server in a data center. But yet the users that are accessing that data have access to it just like they're sitting next to a file server or sitting next to a NAS device. So the performance that they get is like it's right next to them, but yet they're able to share and synchronize data across all of those locations using our architecture. Again, we leverage the benefits of object storage, the capacity, the scalability, the durability of object storage that lives in AWS, that lives in Azure, that lives in Google, and we take advantage of the scalability of object storage because you can have an unlimited number of objects in a given container. And we take advantage of that for our versioning system, for storing multiple copies, for storing large directories, large files, etc. We take advantage of the properties of object storage. The other thing that's important about object storage is data is stored immutably, meaning when it's stored, you don't go back and change that particular object. If you change the file system, you save a new version. And that allows you to set recovery points that are immutable and can be recovered, from a disaster, from a ransomware attack, from the loss of data. All of that information can be recovered very, very easily. That's delivered by our global file system we call UniFS. UniFS was designed from day one to live in object storage, to take advantage of the properties of object storage, the scalability, the durability, the cost effectiveness of object storage. It stores every element of the file system as an immutable object in the object storage system. It's the file data, the metadata, the system metadata, the inode structure, everything is stored as immutable objects in the object storage system. It also stores versions, multiple versions, and going back to whatever point in time the customer wants to be able to recover to. Many of our customers today store all of their versions. Some customers have been Nasuni customers for 10 years. They have millions of versions they can recover to if they need to. And that's a huge benefit, especially when it comes to ransomware. And I'll talk about that as we go forward. Users access the file system through these edge caching devices. These devices are small storage devices. They have a small amount of storage, and they live where the users and the applications are accessing the data. So they can be in data centers, they can be in remote offices, they can be in manufacturing facilities, they can be in the cloud if that's where the application or the user is accessing the data from. The edge device caches active data locally so that the user that's interacting with the file system gets an experience like the device is sitting right next to me. The performance is delivered by the edge caching device. The permanent data lives in the cloud, lives in the object store, but the user is accessing data through the device that's next to them or close to them.
You said, is that physically close?
Yes, physically close.
Local hardware that's on their premises?
Yes, physically close. Typically, it's not hardware, though. Typically, it's a virtual machine. I mean, it does run on hardware, but our image is running in a hypervisor somewhere, ESX or Hyper-V or some other hypervisor locally on the customer's premises or in their office or in their manufacturing facility. So yes, it is local to them. It can also be in the cloud, local to them if that's where their application is. If they're running, let's say, cloud VDI, their access to the data is through a device that lives in the cloud as well. So they can be anywhere. Now, all of this file sharing that I mentioned before is controlled by Nasuni's orchestration center. And our orchestration center runs as a cloud service in AWS to orchestrate the sharing of data across all of the different locations that exist and are part of the file system. I'm going to go into more detail on the orchestration center coming up, but the key is this allows us to deliver a file data services platform that can be spread across the world. And users are accessing that platform as if it's a single device, a single file server for their file data. Our customers manage their Nasuni infrastructure through a Nasuni management console. This is also a small server virtual machine that lives in their environment. They have access to the information about the edge devices, volumes that they're managing, all of the recovery points and snapshot schedules, and everything about managing the Nasuni environment comes through the Nasuni management console. And we also do a fair amount of work to integrate and validate user applications and customer applications so that they work efficiently with the Nasuni platform. I mentioned ransomware. So again, the UniFS global file system within Nasuni is what we call a continuous versioning file system. Our customers can set very granular recovery points by just setting up their schedules to say, I want to save a copy of the file system every minute. And every minute, a new version will be created, and all previous versions that they want to keep are available for recovery points. So they can be very, very granular in terms of recovery points, if you will, in the file system. And they can keep as many as they want, going back as far as they want to millions of versions. Most NAS systems today limit you in the number of versions or snapshots that you can keep. And once you've exhausted those limits, you have to now go to backup systems and other things to recover data. That's not the case with Nasuni. You can go as far back as you want and recover data as far back as you want. And that's very important for ransomware because most ransomware today is very sophisticated. It lies dormant for a while and then attacks. And it generally attacks beyond the time window for which you could recover from a snapshot. So now you're looking at, okay, I got to go to traditional backup to recover. That does not happen with Nasuni. You can go back to any point in time, as far back as you want, to recover your data from a ransomware attack. Now, on the RTO side, it's very easy for you to go into our management console, select a version of a file or a directory or an entire volume that you want to recover to, and say, go, recover this volume. What happens in the background is that we go back and adjust the pointers of the file system to say, this version that was saved on this date and this time is now the current version of the file system. Very quick recovery, just adjusting pointers. That's how we can recover millions of files in minutes, under a minute. When you compare that with traditional approaches, like traditional backup, again, you can only save as many snapshots as the system will allow you to save. Then you have to go to backup. That means you have to copy data from a backup application back into the file system in order to recover it if it's exhausted. Traditional snapshots will shorten that window, if you will, but they do have a limitation. So generally people have to use backup and snapshot together.
Since you brought up ransomware,
Okay.
I have two questions. One is about licensing. You said you go back at any point in time.
Mhm.
Is licensing based on the amount of data stored, or is it based on, how is your licensing based?
That's a good question. So the way we license our software is on what we call the now version of the file system. So the current version of the file system, the capacity that consumes, raw capacity, so raw ingested capacity. All your versions are not charged from a Nasuni perspective. Now, there are some cloud costs associated with those, but we're very efficient in how we store the data in the cloud. First of all, it's data reduced, so it's compressed, it's deduped. We only, from a version perspective, we only store the deltas so that only things that have changed are stored as a new version. If something hasn't changed, it's still referenced from a previous version, and therefore you can recover. So even if you're storing millions of versions in the file system, the capacity that you consume on the cloud side is not a lot greater than what your now capacity is. And you pay Nasuni for your now capacity.
Okay, that makes sense. Thanks. Yeah, the second question with ransomware, how are you syncing the data?
So again, the process changes at the edge. So a file system would change at an edge device. That change is what we call propagated to the cloud. So the cloud version then achieves that change, and then it's synchronized out to other locations that are sharing that data. If there's an attack, we are working on the ability to mitigate that and restrict it to the location where the attack happens, so it doesn't sync out to the rest of the file
But it can sync, because I mean, that's the problem with ransomware, is that you don't know it's there. You just said that. You don't know it's there, and it sneaks up on you, and all of a sudden all your files are encrypted. So if they're able to sync from their device to the storage in the cloud, then the files in the cloud could get encrypted, right?
They could. That is possible today, although we are working on techniques that will prevent that from happening in the future, very near future, by the way. And even if they do get encrypted in the cloud, you still have a point in time that you can recover to prior to that encryption. So you can roll back the file system to that point in time prior to the encryption and have access to your data without having to pay the ransom.
Of course.
The frequency of the snapshots expand over time. So, you say you're taking a snapshot or you're taking an image every minute. Does that become like one day after it's been in there for a year or something like that?
We do not consolidate those today. That is something we are looking at for a future enhancement. But today it's every minute. If you want to set it up for a minute recovery point, it's every minute going back as far as you want.
Okay.
And again, it doesn't consume a lot of cloud storage because we're very efficient in how we store the snapshot information in the cloud.
Okay, but if you're charging entirely on the now consumption, it sounds like you have an awful lot of back end that will eventually you'll need to pay for. Does your business model work?
It does work. It actually does work because we're not selling the cloud side. The customer is we call it bring your own cloud. They contract with AWS, they contract with Azure, they contract with Google for the backend object store. Okay. They pay us for the Nasuni consumption.
Okay, yes, okay.
And again, it's very efficient. So the cost, again, you're using object store, you're using less cost or lower cost tiers of object storage. You don't have to use the high expensive tier. You can use lower cost tiers. So the cost for the customer on the cloud side is very economical when you compare it to other traditional storage methods.
Okay.
And again, we're very efficient in terms of how we store that data in the back.
Okay. Do you actually have like a search capability to go back and look at the? Okay.
We're going to demonstrate some search capabilities coming up in this session. So, all right. So again, just want to reiterate the Nasuni approach with multiple versions that you can recover to as far back as you need to can recover millions of files, petabytes of data in minutes. The key is identifying, you brought it up, the key is identifying the point in time of the attack and the spread of the attack, how much data has been impacted. Once you do that, it's very easy to pinpoint the recovery point and then recover back to a point in time that is good. I mentioned that synchronizing data across multiple locations is a key value proposition for Nasuni. We put that on steroids last year when we added this feature called Global File Acceleration. Global File Acceleration is a cloud service that we built. It's an intelligence-based cloud service that looks at activity within a customer's environment and says, data is changing here, and users or applications in some other location are looking or trying to access that data. Therefore, I'm going to intelligently prioritize the push of the changes from one location to the cloud to sync to the other location so that users can get access to that data very, very quickly. So that intelligence is built into the feature we call Global File Acceleration. And it's significantly improved the performance of distribution of data and syncing of data across multiple locations for our customers. Here's Leo A. Daly. Leo A. Daly is a architecture, engineering, design firm across about 40 locations in the US, sharing data across all of those locations. They were one of the early customers of Global File Acceleration, and it improved the performance of pushing data to the cloud and syncing it to all of those locations so all of their users had access to it about 5x. So a 5x improvement in the performance of distribution and syncing of data across multiple locations. They also happen to be one of our customers that was hit by ransomware, and they were able to recover 130 terabytes of data in about an hour. And most of that time was pinpointing exactly what the scope of the attack was. Once they did that, the recovery time was very, very short, but most of the hour was identifying what was actually impacted and recovering the data to that point in time. So 130 terabytes in less than an hour.
Now, does your product have the tools to help with figuring out what that scope and
We do today. It's a little bit of a manual process, looking at logs, looking at audit information, et cetera. We're building in the automation to that we're delivering later this year. But today we have the tools. It's just more manual inspection to help them identify. Soon it'll be, hey, here's the exact point in time of the attack. Here's what was impacted. Here's the button you need to push to recover. So simplifying that whole process.
awesome?
One more customer example. This is Urban Outfitters. So Urban Outfitters is a global retailer. I'm sure you've probably heard of some of their brands. They were worried about all of the different file storage infrastructure that they have in their environment. And they wanted to consolidate all of that into a cloud instance, into a cloud service, if you will. So they moved about 700 terabytes of file data across a variety of different platforms in their environment to a cloud service managed by Nasuni. And oh, by the way, one of the things that is important for you to understand about Nasuni is that we are cloud agnostic and we are multi-cloud. This customer actually wanted to move their data after it was in a cloud to another cloud. So they decided they wanted to move their data over into Google because they could get a better cost point and they could get access to some services that Google had that this other cloud provider did not have. So in the background, we worked with them to move 700 terabytes and all the versions of their file system from one cloud provider to the other. No interruption to their users at all. Completely, anonymous, I guess, to their user base. And that's an indication of what we bring from a multi-cloud value proposition perspective.
So Russ, I have a question.
Yes.
Storing data in the cloud costs also money, right? Do you have some tools in your solution which allow the users, the organizations to see what kind of data they have, what they're having, if they're having stale data, if they're able to classify by file folder, for file types, etc., kind of ways to get more insights and act more on the data?
And we do have some tools that they can use today through our management console. They do have some visibility into the consumption of the backend cloud storage. We're working on giving them more data insights, more analytics about the data that's stored in the cloud, and to be able to make some decisions about, okay, should this data, maybe even move to a lower cost tier in the cloud? Like, for example, go to an offline tier in Glacier, if you will, if you're using AWS, those kinds of things. We're working on that capability today to make it even more impactful for customers, but you're absolutely right. They're constantly looking at ways to reduce the cost of storage consumption, and we're looking at ways to help them do that.